Okay, so we've looked at vectors, we looked at our projectile motion, and we decided that the best way to know which suvat equation to use is to decide what's missing. Okay, there's all our suvat equations. So we'll go through this question. You can just pause the video and have a look at this and get it all on the page. Maybe not. There's the question, and there's the 4 parts with the marks. Okay, so the best way to answer a projectile motion question is always to draw yourself a little diagram, particularly when there's a vector involved. And the first things it asks us to do is find the initial vertical component for velocity. Usually you'd be asked to find the vertical and horizontal at the same time. But in this case, we have a vector, something like this. It's at a certain number of degrees from the ground. In this case, the question said 16. The ball's being hit with a velocity of 68 meters per second. So if we're color coordinating this, this would be our green velocity, our resultant. Okay, so our initial velocity. So remember, that's made up of our horizontal, goes that way, which we'll call Vx, and our vertical is that way, V. So we've got a right angle here. Okay. So to resolve these, we need to use some trigonometry. Now, there's a little shortcut I taught you in class. H sine theta, sine is opposite, H cos theta. That's effectively doing all your silly old Harry rubbish, but that's what you come out with. Okay, so we were asked to find the vertical velocity, initial vertical velocity. Remember, this is just the initial velocity. I don't want to see that in any suvats. In fact, I don't want to see that in anything. You're just using that to find the vertical and horizontal components. So h sine theta, put that into our calculator, and that should come out with an initial vertical velocity of, in this case, 18.74 meters per second. Okay, 68 sine brackets 16 close brackets. Make sure your calculator is set to degrees for this, or else you'll get some funny answers. Whilst we're here, we might as well work out the horizontal velocity, as in most cases you will be asked to work out both of them at the same time. So h cos theta, again, put that into your calculator, and we're looking for an answer smaller than 68 because that's the hypotenuse. That's always going to be the biggest, and that comes out as 65.37 meters per second. Okay, now that we've got these two, we can actually go about doing something with it. So anyway, that's our answer to part 1. Okay. Part 2 says the maximum height reached by the ball. Now, if we're talking about height, we're talking about vertical direction. Okay, so I'll just move this out the way. So we're going up here like this. It's going to be a trajectory, like always. We now know that our initial vertical velocity, we just worked it out, is 18.74 meters per second. Okay, so that's going up. And we know that it's going to slow down and slow down and slow down because gravity is acting on it until it reaches a final velocity of 0. Okay, now the reason why it slowed down is because of gravity, which is an acceleration of 9.81, and in this case, because our object's going up and gravity is acting down, that's in the opposite direction, so we give it the minus sign, minus 9.81. Right, so now we're ready to do a suvat equation, because we've got acceleration involved, to find our maximum height. That's this displacement here, how far the ball's being displaced. You can forget horizontal motion for now. It's just exactly the same as if the ball was thrown up and thrown back down again. Okay, so suvat equation. So we use suvat. Now that's what we're trying to find. S, our displacement. U is our initial vertical velocity, 18.74. V is our final vertical velocity, which is 0, and A minus 9.81. Now T, at this point, we don't know, so I'm just going to put a little X next to that. So which equation do we use? Oh, one that's got that, and we need to find one that's not got T in it. That's the quickest way. So look back at our suvat equations. That's got T, that's got T. Top one's got T, the bottom one, there, no T. It's one we wrote no T next to in the other video. Okay, V squared equals U squared plus 2AS. So we'll go ahead and write that down. V squared equals U squared plus 2AS. Rearrange it. If you're not comfortable rearranging, do all your steps. Okay, I've got two sections here. I've got that section and that section. So first of all, get rid of this section by minusing U. And then I can divide by what I don't need over here, which is 2A, because I want S on its own. 2A. Okay, equals S. So that's my equation I'm going to use. Now I can put in my numbers. Well, V is 0, so we can just scratch that off. A, I've just got to be careful, is minus. Okay, so I end up with minus 18.74 squared. Don't forget the squared. Sometimes people were forgetting the squared in the test. Divided by 2 times minus 9.81. Okay, put that on a calculator as we see it. And I mean, if you really want to, you can just get rid of the minuses now. But I just say stick it in the calculator so you don't make any mistakes. And that works out at giving us a height that the golf ball went of just short of 18 meters, 17.8 meters high. Okay, so it reached a maximum height of 17.8 meters.